Hi everybody. We're going to find the exact value of some trig expressions, and we're going to use both degrees, some examples in degrees, and some examples in radians. Before you view this video, you should already know what the unit circle looks like, where you're putting triangles inside of a circle, because I'm going to go quickly through this and do a few degrees and then do a few radians. So these are just like quicker techniques for doing this, like on a test, for a test. So the first one we're going to do is sine of 390 degrees. I know that this is bigger than 360, so I subtract 360 here. So we're really looking for sine of 30 degrees. Now I know my 30 degrees is about here. So that's 30 degrees here. And what I'm going to do is I'm going to draw a line straight down. We know our radius is 1, and you should already know the values here of the sides. And this is how I remember doing it. The longer side is going to be root 3 over 2, and the shorter side, the length, is 1/2. Since we're looking for sine, we're looking for the y. So it's going to be 1/2 over 1. So sine of 390 degrees equals 1/2. Okay, let's do cosine of 135. I know that 135 is one of my 45 degree type angles. It's my terminal side is here, so it's 45 degrees. I draw a line straight down. It's supposed to be 45, and I should already know that on the 45 degrees with the radius of 1 or hypotenuse of 1, this is root 2 over 2. Both sides are the same. Root 2 over 2. It's not working for me here. All right. So the x is negative, though. And we're looking for x, because cosine is the x value. For example, if I wrote this down, since it looks messy there. That's the point right here that would be on the circle. So cosine of 35 is negative root 2 over 2. Let's do tan of 300. I know 360 is here, and I know 270 is here. So 300's about here. I'm going to draw this around. That's 300 degrees. And I'm going to draw my triangle up here. So my y is smaller than my x. So my y is larger length than my x length. So I know this length is 1/2, and I know this length is root 3 over 2. However, my y is negative. So I have 1/2 comma negative root 3 over 2, x and y. And we know tan equals y over x. So tan of 300 degrees equals y over x, which is negative root 3 over 2 divided by 1/2. 2's will cancel here, and you get negative root 3. Okay, let's try some in radians. So in radians, let's try another tangent one. Let's try tangent of 5 pi over 4. And just remember on the 45 degree ones, the ones with 4 in the denominator, I'm going to cut these in half here. Let's see. I'm going to cut those in half. With the 45 ones, this is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now the one we want is 5 pi over 4. So we're in quadrant 3. I'll take all this back out. And our angle goes around this way. And I need to know my x and y value. I know that's a 45 degree and that these are the same. And I also know in quadrant 3, x and y are both negative. So this is root 2 over 2, negative root 2 over 2. So my x and y is negative root 2 over 2, comma, negative root 2 over 2. I know my tan is y over x. And when you divide negative root 2 over 2 divided by negative root 2 over 2, that equals 1. Okay, so that's my answer. That's why tan is always positive in quadrant 3, because you're dividing by negatives. Let's do a secant one. Let's see, we have secant 9 pi over 4. I know this is bigger than 2 pi, because 8 pi over 4 is 2 pi. So I'm going to take 9 pi over 4 and subtract, and I get pi over 4. And like in the previous slide, pi over 4 is in this first quadrant. I'll draw the line down. I know the in quadrant 1, both my x and y are positive. And secant is going to be r is 1, is going to be 1 over x. So this is going to be 1 over root 2 over 2. And I do have a video on dividing practice, but basically what this is 1 divided by root 2 over 2. And if you remember in 4th grade, you just change the division to a multiplication sign and flip the side on the right and multiply. And that's going to give you 2 over root 2. All you have to do is just flip this in the denominators, 2 over root 2. And rationalize it. And you're going to get secant of 9 pi over 4 equals 2 root 2 over 2. 2's cancel, so you're left with root 2. How about cosecant? Let's try cosecant of 5 pi over 2. So you know you're going to have to subtract 4 pi over 2, which gives you pi over 2. In this case, we just need to know, I'm going to draw a circle here, what this point is. If my radius is 1, it means my x is 0 and y is 1. And I know cosecant is r over my y. My y is 1, so this is 1 over 1, which equals 1. So cosecant of 5 pi over 2 equals 1. So basically what happened is we went around once and then back up to here. That's 5 pi over 2. Is there any other interesting ones here? How about tan of 7 pi over 6? We'll do one more. So we have tan of 7 pi over 6. I know 7 pi over 6 is in quadrant 3. I know if there's 6 in the denominator, that should be a 30-degree one. So this is pi over 6, 5 pi over 6. This, if you do the angles here. And this would be the 7 pi over 6 one. I know my longest length is going to be root 3 over 2. In this case, that's negative root 3 over 2. And my shorter length is the 1/2, but it's negative because we're in quadrant 3. And you're dividing y by your x. Those cancel, so you're going to get 1 over root 3, and you can rationalize it, and you get root 3 over 3. So tan of 7 pi over 6 equals root 3 over 3. And that's all.